Hello, we are doing problem 10 today. And it is determine whether a linked list is a palindrome or not. So I drew out the input example. This is a random one I got that everyone uses. We could also do something like the word race car or something. But palindrome is basically a a list or a list that's the same from beginning to end. Oh, mirrored. Yeah, that's the word, mirrored. So yeah, so it says the prompt says, given a singly linked list of integers, your task is to complete the function is palindrome that returns true if the given list is palindrome, else return false. So what we have to do is make sure that our list is palindrome and the return true or false. So relatively simple. It's a bool that we have to return. Yeah. So if you look at our example is a palindrome. Because it starts at 2, it starts at 1 and then 2 and then 2 again and then 1 and it ends. So yeah, it's the same. There's multiple approaches to this. I personally like the one that takes up a little more space, using the stack call recursive stack function thing, because we don't manipulate the original input. But the one that I see everyone use because it's more space efficient is like where you traverse with 2 pointers and you stop in the middle and you reverse the other half and then you compare it. I really don't like that method. I understand it and I could write it, but I just don't. Okay, yes, you save a little space. Which depending on the size of the input, um, like it could be worth it, but to me, I just did not like it because you manipulate. What if you need to use the original input for something else? But if you manipulate it, that fact that it's now reversed, going towards the center, like so it would become like, I don't want to keep it because I don't want to draw it. I just don't like the method. So, oh sorry. So it would be like this. You know what I mean? Um, and then we kind of go, okay, since like this and this is reverse, this is this, because we can't just, unlike an array, it can't just go anywhere in the linked list, right? So if we have a slow pointer and a fast pointer and the fast is at the end and the slow in the center, then we could just go, okay, like, you know, are they the same? Yes, no, and then we can go that way. But yeah, I don't like it. I think honestly any other method. So that method is what's popular because it's the only one that uses constant time, or sorry, constant space. But I yeah. But the I mean honestly, I'm not gonna do this one, but I would honestly prefer if I was like to convert the linked list to an array and then find if it's a palindrome in the array and then return, because we only need true or false. Like we don't need to return the like linked list or anything. You know what I mean? So it's like, why don't I just do that? Obviously, it takes more space because we have to make an array, form the linked list, and then perform a check on the array. But I'm just like, yeah, it's more intuitive. So I think the middle ground to this is just using a stack. Um, yeah, I don't I mean I there's something about reversing partially a linked list that was given to us just feels wrong to me. So that's my personal opinion. um Maybe it's because I'm new at this. I just don't like it. So it's like it's unnecessarily complicated for a little bit of space efficiency. It's just like I don't, and we have to change the original input. It's just kind of a big deal if we ever need it. And then we're gonna have to go, well, what just happened to this? And this, it's just potentially a lot more bugs. in the future if we do this. So I'm going to do the stack method, which is essentially, so it's a linked list, so we have to traverse it once. So it's going to be the time complexity for all of these methods is, all the ones I listed is linear time. That's just because it's a linked list. So it's, I mean, at best, it's, yeah, linear. And then the space, I think, um, it's a stack. So we have a recursion and then whatever. So I'm pretty sure space is also this. Is also linear, so it's not going to be constant if we were to use reverse the partial linked list. But yeah, I'm just going to go with this one. Because it doesn't, the original problem doesn't say a preference. It just for how we should approach it. It just says your task is complete the function and its palindrome return true. So I don't think it matters which way we do it. So I'm gonna do the stack way. So the stack way is cool because we traverse the linked list once, and then we sort of push on everything we traverse onto the stack. Oh, let me change the color. So like the stack would be like 1 and then 2 and then 2 and then 1. So that would be the call stack. Yeah. So we're gonna push all the elements of the linked list onto the call stack and just append it. And then we're going to go through the list again. And we're going to pop the first element, like the topest element, so like 1, off the stack. And then we're going to compare it to the sorry, I missed one important step. So we're going to have a head, and then we are going to go through it one more time again at the head, and then we are going to be able, that way we can compare whatever we pop off to where we are at in the second time we're traversing through. So like we're gonna pop off 1. So let's say we pop off 1. So we're but we're starting off at the head still. So we pop off 1 and then we compare it to the head that we're at, and then we go, are they the same? Yes. Okay. So does that make sense? So like, I mean, you know how it works. You know the answer to these. But hopefully I'm explaining it right. Is like, is head the same? And then if it is, then cool. Then we have a palindrome, and then we do the same to this. So we go on 1 more, and then we pop off 2, and it's like, is it the same as head? And it is. And we kind of do that until the very bottom, or until we find something that isn't the same. And if so, we immediately break out because it would not be a palindrome in that case. So yeah, pretty. That's why I like this method. Just, there are certain things. There's a reason why like stacks are like invented, and I feel like this is not obviously the primary reason, but like it's to make things like this easier algorithm wise. It's just I saw the recursive solution, and it's like a lot of times for a beginner, I'm like, does it really need to be that complicated? Because it's not any more efficient. It's not, it's just, it's the code. It's just scary and confusing. Anyway, so yeah, that's the code. That's what we're kind of gonna do. I'm kind of debating if I should get a smaller sized pen. No. Okay. I'm sorry. I don't know. I don't know why I feel like my pen strokes today is like bigger, and I like the thin ones because it allows me to write more in a smaller amount of space. So basically we're going to go, okay, we're going to define as whatever, and then we're going to have it head as input because that's where we're going to go in at the start. So I guess head is like linked list. Okay, so yes, determine whether a linked list is a palindrome, and then now we're going to very important, we're going to construct an empty stack using DQ, which is, because in Python there's no Like we have queues and DQ, which is basically stack, I think. So, yeah, so many reasons to love Python. Not having to deal with the syntax of stacks is one of them. What was I saying? Yeah, so we're going to give me a second. So we're going to declare a node at the head, and then we're going to use this. Oops, that's not it. And then we're going to use this node to traverse. So while node is not none, we're going to append the node, the data, I guess, of the node to the stack. I think, well, I could probably, so I don't know if it matters. I don't think it matters, but let me actually, because I'm not used to, I mean, it doesn't matter, but I'm going to do .val because that's what I've always traditionally used. I don't associate data with linked list nodes data, even though it does make sense. Then we're going to increment the node by 1 so we can move forward on the linked list. And then, yeah, so we have pushed this part, we have pushed all the elements of the linked list onto the stack. And then now we're going to go start from the beginning. It's deja vu. We're going to go and start at the head again. And, well, the same thing, while no, oh, my writing's terrible. But do you see how pretty the strokes are? My writing is horrible right now. I'm barely putting in effort to write well. But the strokes are so nice and pretty. Here, I don't even mind it. It just looks like my handwriting. So yeah, while node is not none, we're going to save the top of the stack. And we're gonna pop it out, which is automatically gets saved to top. And now we're just gonna compare if top is equal to node.val, which is something that we have right here, and that if not, then we just return false and we break out. So easy. And then we're going to go to the next node, just like before. Node.next. And then if this never happens, then we just return true, because that means it is. Oh, that's terrible. Because that means that it is a palindrome, and that's it. So 2 transversals, 1 stack. But look how nice and understandable the code is. It's beautiful. Yes. And that's it. So yeah. So this is time complexity and space is both in they're both in linear time. Let's see, is there anything else I should mention? So yeah, we talked about other solutions like reversing the second half by having a fast pointer and slow pointer and stuff. Just converting it to an array and then deciding it was true or false there, blah, blah, blah. So yeah, that's it. Okay, see you. Oh, it's this last video. I haven't recorded 7 yet. So see you at 7. It's going to be so tricky.